Some additional concentration units that we'll see in this class are percent composition. So this is a way of defining, this is often used for things that are either very concentrated or very not concentrated. Well, it kind of works regardless, just based on the definition. And so there are two different ways of doing this. We can know something by weight percent. And so this is a mass of solute versus the total mass of the mixture. And again, this mixture doesn't have to be a liquid. So weight percent can be used, for example, for looking at alloys. You need to know the composition of, say, steel. What is the weight percent of carbon in steel? This might be a way that you define this. And to write this as a percentage, then we take this and multiply by 100%. Let me move that out from behind me. All right, so then we can also define this in terms of volumes, which then you take the volume of solute divided by the total volume of the mixture times 100%. Okay, so some places you'll see this percent composition show up. For example, our very concentrated solutions of acids and bases are often sold in terms of a specific weight percent. We'll look at an example of this in class and do some unit conversions between these different types of concentration units. So it's pretty common to buy these by weight percent and then need to convert to a molarity to be able to actually find concentrations that you want to use. Kind of a subset of this percent composition is we can take something that's in very small quantities and write it in terms of, instead of a percentage, we can do what is known as parts per million. So percent is, thinking about per 100, right? That's what percent means. But we can also think about, for a million things, how many out of those are the solute that we're interested in. This is a concentration unit I use quite often in my research. I do trace gas analysis in my lab. And so parts per million is a very common unit used for trace gases concentration in the atmosphere or in human breath. Those are two sorts of samples that we're interested in studying in my lab. Anyway, parts per million is abbreviated ppm. And it's basically the same as parts per million, and we also have parts per billion. These are essentially the same as the weight percent, but instead of a percent, it's a per million. So we have the mass of substance, you could say substance or solute here, divided by total mass of the sample. And then since it's a per million, we multiply by a million, by 10 to the 6th. Parts per billion, which is abbreviated ppb, is the same thing. Mass of substance divided by the mass of sample times 10 to the 9th, so times a billion. Okay, so that's just definitions here, different types of percent compositions that we can write out. And again, these parts per million, parts per billion, these will show up pretty commonly when we're thinking about very low concentrations of things. It's a lot easier. You end up with less scientific notation you have to worry about. It's sort of built into the unit. When we're thinking about aqueous solutions, we can make some assumptions about the density of the solution. So 1 part per million, for example, is going to be equal to 1 microgram of solute per gram of solution. And this is just based on the definition that we had above, right? If we write it instead of, if we write this in terms of, if we think about 1 gram, every 1 microgram of that will be 1 part in a million, right? Because micro is 10 to the minus 6th. All right. And if we say we know that 1 gram of water is about equal to 1 milliliter, so this is using the density of water. So this is an approximate value, right? If the density is very different from 1 milliliter, this actually doesn't work. But usually we're thinking about small amounts of something in water, so the density of water is going to be pretty close to 1. This will give us a 1 microgram per milliliter solution. We can take 1 ppb and do the same thing for. So to be clear, this approximation is only good for aqueous solutions, but we'll get this is approximately equal to 1 nanogram per milliliter for an aqueous solution. For gases, this is just for me. We won't actually use this in this class, but ppm and ppb, when used for gases, are used for volume instead of mass. Sometimes they're even written with a V at the end to make it clear that they're volume, parts per million in volume instead of in mass. Like I said, we won't actually use that in this class. We're not doing any gaseous analyses of trace gases or things like that. But just to be complete in terms of the presentation here.